Well, welcome to Communication Engineering Lab and course ECO 850, Communication Networks, which is an open elective course for your 8th semester. I am here, your instructor, A. Chandra, probably you know about this. We will have regular classes on Monday, Wednesday, and Friday from 9 to 9:45. And so please be on time so that we can complete the course on time. Well, I know that this is an open elective course and I will trouble you much with this course. So we will have exactly 20 classes, and within these 20 classes, we will finish this course. We already have planned out almost everything, how this course will go on, and we have updated the Moodle page. So many of you have already registered in the Moodle page. If you have not, please register, because all the course materials, everything will be available there. Every class will be recorded and the class record links will be provided in the Moodle page. So the single page will provide you a platform to see the classes offline, to get the materials for the course, and also from that Moodle page you can submit your continuous assessment and final exam as well. So there will be a single window kind of thing. So now I will just quickly share you with the Moodle page. Many of you already know about this. Some of you probably don't know. So for them, I'll just give a quick introduction of the Moodle page. So this is how the Moodle page looks like for the course Communication Networks. At the beginning, we have a Google Meet code. So if you forgot or if you misplace, you can always go back to this page and connect to this. You have to just remember the class timing. The textbooks I have provided, but probably you don't need to buy these textbooks because I have already provided some pages in the Moodle page itself. Okay, so we have the course divided into 4 modules, Module 1, Module 2, Module 3, and Module 4. We have already got 2 CAs, Class Assessment, Content Assessment 1 and Content Assessment 2. And after Module 4, we will have our final exam. So this is how this looks like. And when you register for the course, you will be shown as a participant. Well, it is very important for the participants to mention your roll number in the student ID field. Otherwise, it will be very difficult for us to evaluate your marks at the end. I can see that most of you have done it, but some of you have not. So I request you, like for example, Sayok Acharya or Shubham Agarwal or Shubhra Santa Chakraborty, for example, or Ashish Jaiswal. So they have not put their roll numbers in the student ID field, so it will be difficult for me. So please, after this class, go back to your Moodle profile and update this link. And in this page, as I have shown that for every module, the syllabus, the corresponding lecture notes are given. The lecture video links will be populated here once the classes are over. So that's all for the Moodle page. Now we go back to our regular class. So we have a course called Communication Networks. And I want to spend some time on the title of the course. But before the course, let me remind you once again that we will try to finish this course as early as possible. You can see from the Moodle page that we have planned for 20 classes. So it will be exactly 20 classes, nothing less, nothing more. And we'll try to make the course at a very preliminary level. I know that we have students from computer science and electrical as well. So for those people, the course might seem very preliminary. I'm sorry for that. But we have students from BT, chemical, metallurgy, mechanical, civil as well. So, and they might not have any introduction to electronics or computer or electric circuit branch techniques. So we will try to make the course suitable for them, and that's why it might seem sometimes for the CS or EE people that the course material is very elementary. The second thing, that is the overall objective of the course. Well, with this course, I don't expect you to become an expert of ECE or CS or something, and neither I probably expect you to become an expert on communication networks. Then what is the goal of this course? The goal of this course is, of course, you will be joining your respective core branches or probably some interdisciplinary branches. But wherever you go, you will be working with some engineering devices. most likely with a computer or a wireless device or some industrial devices. And those devices are capable of communicating or networking. Now, when you are going to use those devices, of course, you are not in charge in a company or in an organization of those devices. There will be some system administrator or a network administrator kind of guy. But when you are going to interact with them, you should be talking in engineering terms. Like you might be provided with a computer when you are working for, a, say, for example, a mechanical company, and all your job is to draw CAD drawings and something. But sometimes there will be some networking issues, and you need to contact the network administrator. Now, when you are going to contact the network administrator, you should not simply say, like a layman, that, hi, Ravi, can you see my computer is not having any internet? So that's what a layman would probably say. So probably you can have some basic troubleshooting kind of capabilities. You can judge on your own what might be the problem. And then if you can't fix it, then probably you can run to the network administrator. Similarly, if you are working on a field, probably there are some devices which will be communicating with themselves, like some sensors, some actuators, some motor pump, and so on. Every devices in the new generation are going to be networked. So in those cases also, probably you can do basic debugging or basic understanding of those devices, how they work. And when they are installed, probably you can understand how they're interconnected with each other. But of course, you are not an expert of that. So the goal of this course is to introduce with some basic terms, terminologies, and basic understanding of how communication and networking works. And with that, probably you can apply this knowledge to your chosen field, and then probably you can interact better with a network administrator or a system administrator or a communication engineer who might be in charge of those devices. So that is the goal of this course. So neither me nor I want you to be an expert of these things within these 20 classes. So I hope the goal of this thing is clear. And I have been teaching such kind of open relative courses for quite some time. So I know where the pain is. Probably you always feel that there is some extra load with this. So we'll try to minimize that load as much as possible. And we'll try to make this course as fun and probably related to the daily life things as much as possible. In the course of the in our course, we will have 4 modules. We will have a basic introduction. In basic introduction, I will be talking about what is communication, what is networks, and so on. And then we will move to module 2, which is computer networks. Well, computer networks is very important because everybody is probably already using or going to use it in an extensive way, the computer networks. So you should have a basic understanding. Again, we have CS people, and they probably know much more than me about the computer networks. So probably that part seems very redundant to them. But for all others, we are probably not an expert in computers, but we want the computers to get connected and take some or get some basic understanding of how the communication takes place. So that is about module 2. So there we'll be talking about something like what is IP address and something like that. And then we'll be also talking about how when you browse a page, for example, which page exists in US, how this information is carried all the way from US to your computer, and so on. So this kind of basic understanding we'll do in module 2. In module 3, we'll be talking about wireless networks. Well, we are surrounded by different wireless networks. Everybody probably uses a cellular mobile phone. You probably use Wi-Fi technology. You are probably have some knowledge of basic Bluetooth as well, or actually an user of Bluetooth, and so on. So what these technologies mean, how these are going to change the shape of the future of the next generation industry, we will try to understand that. And there is a big roar of 5G as well. So if time permits, we'll be talking about a little bit about what is 5G, how it is coming, and how it is going to probably change the scenario in Indian as well as international market. So that's module 3. And finally, in module 4, we will be considering industrial communication networks. So what is industrial communication networks? Well, in industrial communication networks, we'll be talking about things like IoT, Internet of Things. Then we'll be also talking about something like vehicular networks and other things which are interdisciplinary in nature. We need mechanical people and other people all together to contribute together, having next generation networks. So these are some introductory things which probably we'll be working on in the company. And also in a plant, for example, in a process plant, you have some level indicators, you have some strain gauges, so they are going to communicate with the central server. So how that takes place, so that is in module 4, and with these 4 modules we'll end this course. So that's the outline of this whole course, and if you have forgotten the outline, never mind, go back to the Moodle page, see the outline, and probably you can understand how we have structured the course and how it might be relevant to your discipline. Okay, so the first we will start with the title, communication networks. In this title, communication networks, there are 2 terms. The first thing is communication, the second thing is networks. We have to understand these 2 terms quite well so that we can have a smooth flow with this course. Well, communication is what currently we are having between us, like we are having a communication, verbal kind of communication. So whenever 2 people are, suppose, standing next to each other and they are talking to each other, well, we have some kind of communication. So that's fine, or that's very easy to understand. But we take probably a abstract look at this. That is, for any communication to take place, there should be 3 entities. What are the entities? A person who probably speaks, a person who probably hears, and there should be something in between which carries the voice. So in any communication, if you consider in a block diagram approach, there are 3 blocks. One is a transmitter, one is a receiver, and in between there is something called a channel. So these are the 3 basic blocks of any communication system. If you are talking to a person face to face, then you are the transmitter, the person who is listening is the receiver, and the air medium between you is the channel. When I am talking to you right now, obviously I am the transmitter right now and you are the receiver, and there is a channel in between us, but the channel is very complex because I have a microphone, and this microphone is going back to my computer, and then probably it is connected to some internet cable, and then it is going through some servers again to your computer and or the mobile phone, and then probably you are getting it. So the channel is quite complex and multi-hop, but there is obviously a channel. So this is what we mean by communication. Communication is quite old. People used to communicate as soon as they got civilized. But when we talk about engineering communication, we generally talk about electronic communication. Now, how the idea of electronic communication came into place? Well, let's stick to the basic diagram that a person is talking to another person, and why engineering comes. Well, if 2 persons are sitting side by side and they are talking to each other, then actually no engineering is required. What you need is probably an air medium between them. If the 2 persons are sitting side by side on moon, probably they can't talk to each other unless you have some engineering, because there is no air medium on moon. But on Earth, on a bench, on a park, if 2 persons are sitting side by side and they're talking to each other, in that kind of communication, no engineering is required. But think about a scenario where the 2 persons are not so close to each other. The distance between them is increasing. Suppose this distance between them is increasing. Let us consider for example, a gathering where some political leader is giving a speech, and that speech has to be conveyed to a lot of people who are sitting around. But the gap between the speaker and the listener is of the order of at least tens or hundreds of meters. So when you have, suppose, a distance of around 1 meter, then our vocal cords are good enough to transmit the signal to the ear of the listener. But when the distance is something of the order of tens or hundreds of meters, then when you shout, still your voice might not be good enough to reach to the listeners. So what they do in probably a gathering, well, they use some kind of microphone and loudspeaker. So what kind of microphone and loudspeaker things are? Well, here, obviously, we are again transmitting voice, but we are transmitting enhanced voice or large amount of voice or high power voice. So some kind of engineering is being done at the transmitter end. So we have a person standing on a podium, and then there is some person sitting here, and this distance is suppose hundreds of meters. Then what this person do? This person speak over a microphone, and then this microphone is connected to a loudspeaker, and then this loudspeaker signal goes to this person. So here we are engineering the transmitter side. What kind of engineering we are doing at the transmitter side? Well, we are taking the voice signal. We are having a transducer. The transducer is converting the voice signal to electrical signal, and then we amplify somewhere in between, and then convert again the electrical signal back to the sound signal, so that the sound signal is now amplified and it can reach the receiver. So this is where the engineering comes, because our vocal cord cannot generate a sound beyond a certain level. So that's some engineering done at the transmitter side. Fine. What we need for this kind of thing, and why we need such kind of microphone and loudspeaker? Well, we cannot amplify the sound in the sound domain. Like, there is no single box in engineering where the input is sound, output is sound, and we have an amplifier in between. Sound cannot be amplified on the sound domain itself. We have not figured it out yet. So what we have done? Well, we can amplify electrical signals. That we have done with electronics, electrical, and many other kind of things. We have figured out boxes which can have an electrical signal as input and an amplified electrical signal as output. You have all gone through basic electronics course, and probably there you have read about some amplifiers. So those are capable of those things. So now the problem is, you have sound signal, but you can amplify electrical signal. So you should convert sound to electrical signal, which is done via a microphone, which is a transducer, converts sound signal to electrical signal. And once amplified, the electrical signal should be converted back to the sound signal, which you do with a speaker or a loudspeaker kind of thing, which is another transducer, which is converting electrical signal back to the sound signal. So this is what you are doing the engineering at the transmitter side. Fine. And this arrangement goes well when these two persons have a distance of 100 meters. But suppose we have longer distances, like we have our prime minister or chief minister talking to some people, but they are not contented with the people sitting around them. They want their information to be transmitted to other states or probably other districts, people residing at that end as well. Now, when the distance between the transmitter and the receiver is of the order of kilometer, tens of kilometers, then whatever microphone loudspeaker arrangement you can probably devise is not good enough to transmit the signal to the receiver end. Our ear cannot pick up the such faint signals. So what you can do? Well, now people are thinking about, we have done engineering in the transmitter side. Now we should do some engineering in the receiver side. In the receiver side, we are not capable of picking up faint signals with our ear. So let us make some very sensitive device which can pick up very faint signals which our ear cannot. This is where the term antenna comes in. So people have devised a device which is called an antenna. Antenna is good enough to pick up very faint signals. How faint? I will give you an idea. An antenna can pick up a signal which is of the order of 10 to the power minus 12 watt, which is very, very low. If you consider a speaker is capable of transmitting signals at the level of several watts. And the mobile phone signals are of the order of, say, 10 to the power minus 3 or 10 to the power minus 4 watts. And here an antenna can pick up as faint as a signal of around 10 to the power minus 12 watt. So an antenna is a very good device. Fine. So is it good enough that you can attach an antenna directly to a person's ear? Well, unfortunately, no. Because the antennas, again, can pick up not sound signals, but they can pick up electromagnetic signals. Why? Can't we make an antenna which can pick up sound signals? Yes. But the antennas will be very, very large. How large? If you want an antenna to pick up a sound signal, then the antennas should be as large as several kilometers. So that is not a practical approach. So for a practical antenna, it can only pick up electromagnetic signals, RF signals, radio frequency signals. Well, the signal that is being, or that we want to transmit is suppose voice, but we have engineered the receiver side which with an antenna that can pick up an radio frequency or an electromagnetic signal. So what is the way out? Well, then people thought about, let us convert our speech to electromagnetic signal, let us transmit the electromagnetic signal, and let us pick up the electromagnetic signal via an antenna, and then let us convert the signal to the voice signal or sound signal once again. Then probably this long distance communication can take place. So this is the origin of the radio. Like somebody is speaking, performing a play, giving a news bite or something at a radio station, which is in voice domain or sound domain. That sound signal is converted to electromagnetic domain, that is being transmitted through some antenna, and then it is picked up by another antenna quite long distance away, several kilometers, several thousands kilometers even. Even you can pick up a signal from BBC, which is being sent from UK, which is in London. So that is possible. And once you pick up a signal via an antenna in a radio, then in the radio you can probably convert the electromagnetic signal back to sound signal with some processing. What is inside the radio, how this processing does, that is beyond the point of our course, and we are not going to attempt to those things. For those EC people are there, they are doing that work. For us, it is good enough to know that okay, we can pick up with an antenna a radio signal, and then you can convert. Where is an example of a radio? Well, if you drive a car, most of the car is now having an FM box. So that FM radio that you listen while driving a car is an example of such thing. FM radio stations are several kilometers away. What I know from Durgapur locality is the nearest FM radio station was in Asansol. So probably you can sometimes pick up the signals here as well. In Calcutta, there are many radio stations, and in every metro cities, like you are from all over India. So in every metro cities, and even in some class B cities also, you have FM radio stations. The range is not big. The range is around say 10-20 kilometers, but we can have other kind of radios, not only FM radios, which have higher ranges. The whole idea of this discussion was that communication can take place between two entities. These two entities, most common example are two persons, and most common example of communication is voice. Now, when the distance between these two entities increase, we have to do some engineering in the transmitter side or in the receiver side or on both sides, so that even although the distance between these two entities are increasing, still we are able to communicate. So that's the basic idea of communication. You might ask that whether we are going to communicate voice only. No, not of course, but we have taken the example because it is very easy to understand, and it is our first class, so that's why I'm sticking to voice. But we can transfer a file, we can share a song, we can share a video clip and whatnot, text, image, video file, everything we can send, and we can send it through such kind of engineering. So that's why communication engineering is so important when there is a distance between them and you need to transfer. Also, here I have shown you an example of wireless communication, but not all communication are wireless. There are wired communication as well, like the old day landline telephone, and current day we also have optical fiber cables through which we receive internet signals. So we have wired signals, wired channels. We can have also wireless channels. Depends on the application. So we will try to cater to all these things one by one. But in the beginning, probably you have got a basic idea of what communication is, what are the basic blocks of communication, and why we need, most importantly, communication engineering. Now, after we have talked a little bit about communication probably is not a very, or communication engineering might not be a very relevant term to many of you, but probably you have heard the term network a lot, like social network and so many other kind of things. So let us now talk about the second term of the course, which is networks. We have talked about communication a little bit. Now let us talk about networks. Because our course is about networks, we are not going to talk about much about communication engineering. Okay, so when two persons or two entities rather communicate with each other, it is called something like P2P. What is P2P? It's something like the catch terms B2B, business to business, B2C, business to customer, something like that. P2P. What is P2P? P2P is point to point. There is one point, there is another point. So this person or this entity or this device, this might be a computer, this might be a cell phone, this might be a printer, this might be a fax, anything, is communicating to another point. This is kind of P2P thing. But P2P communication is not always enough. Let me give you an example. In EC department, we have got one color printer, color laser printer. Color laser printers are costly, and when the color laser printer came, actually we had the budget to buy only one color laser printer. For some cases, we required some color laser printers. Now, when the color laser printer came, obviously there was an issue where the color laser printer will be. Obviously, our HOD wanted that the color laser printer should be in his chamber. Other professors wanted that it should be in their chamber. So there was a tussle, like where you should put the color laser printer. Then we suggested that, okay, fine, we will put the color laser printer in the office, but we'll make sure that everybody can make the use of this color laser printer. That's a very costly resource, and probably everybody wants to use it, but it should be monitored as well, because we cannot keep it in the open. So there is a possibility of misuse. So to avoid misuse and to give access to everybody, let us make an arrangement that we will put it in our ECE office. There is an office staff who can monitor it, but we will put the color laser printer on LAN. That means we can all communicate to the color laser printer. So if I have a machine in my, or PC in my office room, then I can also send an print instruction to the color laser printer. All other professors can also do that. And it's not a personal property of HOD or a personal particular professor. It is a property of everybody. So this is an example of why we might need networking. When we need a very costly resource that has to be accessed by everybody else in a time shared manner or in some other kind of sharing manner, then we need a network. So we don't need only a connection between the HOD's computer and the color laser printer, but we need a connection between all professors' computers and the color laser printer. So that's a paradigm shift. So what I was talking about so far was a point-to-point communication, but now what I am talking about is like a network, where there is one entity which has to be connected with several other entities. And there should be at least 3 such entities to make a network. So 2 persons make friends, 3 persons makes company. So that's something like that. When you have 2 persons, they can communicate, but you need at least 3 entities to have a network where everybody is connected to everybody else. So this is the idea of a network. This person can talk to this person can talk to this person, and so on and so forth. So when you have at least 3 such entities which can communicate with each other, then we form a network. Of course, in modern networks, we have much more number of entities which are capable of communicating with each one. So that is the idea of network, but I will develop on this. Before that, I would like to, we have got at least, I think, 16 people. So sorry, we have got at least around 25 people. So I would like to know from you that what is your idea of a network, like either what network you might have used, or what network means to you, or what why a network might be useful, anything that comes to your mind with the term network. Please write in the chat box. I'm looking at the chat box right now, and give me a feedback like what network means to you. It will help me. So I repeat my question. Please write whatever comes to your mind when you hear the term network. It might be a definition, it might be an example, it might be an application, it might be a device, anything. Okay, so Mohit is fast to write, and he has written about Wi-Fi devices, Bluetooth and LAN. Great. So the first two are wireless networks. The third one is a wired network. Okay, so these are examples. Anything is fine. Definition, example, devices, anything is fine. Okay, except Mohit, anybody else? Okay, next is Soikot, and he's saying about multiple devices connected to share resources. Fantastic. That's what exactly I was talking about. Okay, Nilabro is next. He's talking about chat protocols like IRC that allows people to chat with each other. Great. So probably we have such kind of facilities in modern social networks like WhatsApp or Meta or LinkedIn and so on. Okay, anybody else? By the way, Nilabro, what is IRC? Okay. Internet related, right. That's quite nice to have such interactions. Okay, great. Anybody else other than Mohit, Soikot, and Nilabro want to share what the idea of network comes to your mind? It need not be very sophisticated, you see, because at the beginning we are all laymen. So whatever comes to your mind with that word network. And actually we have only very few minutes left, so we'll be wrapping up this class as quickly as possible. So I'll just wait for one more minute. Okay, nothing yet. So I have got Mohit, Soikot, and Nilabro. Fine. So we have got some ideas of what network might mean to you. Now, when I am drawing such diagrams on board, well, I am drawing some circles, I am drawing some lines. So that are the basic entities, or that are the basic constituents of a network. A network is made up of two things. A network is made up of nodes and links. So when I was talking about the color laser printer and when I was talking about the PCs, those were the nodes which were generating the information or using the information, and there should be some cable or wireless connection or something in between them, which are the links which carry the information. So if you consider the network as an information sharing system, then the nodes are those who generally generate or consume the information, and the links are the in between things which carry such information. So if you consider network from an information transfer perspective, then informations are generated at some nodes, information are being used at some other nodes, and there is some entity in between which is carrying the information, which are links. So when we draw such a diagram, this is a node, this is a node, this is a node, and these are links between them. So in our office example, the PCs and the laser printer were all nodes, but the Ethernet cable which were connecting them with each other were the links. So when we consider the type of nodes, well, there are generally two types of nodes. The type of nodes that I have just talked about are all terminal nodes. Well, I write this. They are called terminal nodes. But there can be some nodes like communication nodes as well. So what is the difference between them? Well, when you see your, I hope you have seen your hostel corridor long ago. But when you have seen your hostel corridor, probably there is a box at the end of the corridor, and there is a metal box. Inside, there are some green lights blinking, and you probably know that is a switch, which is probably useful for your internet connection to your room. So those are also some nodes which are in a network, but they are neither the direct generator of information nor the direct consumer of information. So when I consider my EC department, in EC department we have say 3 floors, and here probably HOD is sitting with his PC, and here is the color laser printer. Now when there is a connection, the connection is not directly between them. There is a node here. So what is this node? This node is generally a switch, which or a router or something like else, which is a flat metal box, big, where many of the jacks are going in and there are green lights are blinking. So those nodes are communication nodes. So when you consider a communication network, then there are generally 2 type of nodes. One node is generating the information, one node is probably consuming the information. Both these nodes are of the type terminal nodes, because the network actually terminate at those points. But there are intermediate nodes which only carries the information from one part of the network to other part of the network. Those are known as communication nodes. These communication nodes can be a hub, this can be a switch, this can be a router, they can be an access point, they can be telephone exchanges, and so many. So while we will be talking about communication networks, we will be focusing on these nodes, because we are not reading about device technology. We don't want to know how a printer is being constructed or how a PC is being constructed, but we want to know more about these intermediate nodes, because those nodes are generally not talked about, and probably we want to explore a bit more about them with this course. So that's about nodes. What about links? Well, links are these things which are connecting the PC with the switch, or switch with the printer, and so on. Now these links can be differentiated in many ways. First of all, the most common way of differentiating them is by looking at them, how they look like. Is it a cable like a twisted pair cable, or it's like a cable TV kind of cable, or it's an optical fiber cable, or it's wireless? So whether it is wired, whether it is wireless, if it is wired, how the wire looks like. So that is a kind of physical differentiation of links. But we are not much interested in physical differentiation of the links, because that is again the duty of the cable manufacturers. We are more interested in communication network discussion, is that how these links behave, or how these links carry the information. Well, these links carry the information in many ways. First of all, you can differentiate them in direction of information transmission. Some links carry information only in one way, some links carry information both ways but not at the same time, and some links carry information in both ways and at the same time. So they are known as simplex, half duplex, and duplex. I'll be talking about this in our next class a bit more. And then there are links which are about this kind of things. There are some kind of links, these are like this, some kind of links, they are like this. Like some kind of links which are only for communication, some kinds of links, they form a network. So these kind of links are point to point, and then here we can have some shared kind of links. So more on this on the next class, when I'll be talking about nodes and links and their types. But before we leave, let me just quickly summarize what we have done in today's class. In today's class, we have introduced you the course title, Communication Networks. We have briefly talked about what communication is about and why communication engineering is required. And then we moved to the next term, which is networks. And we said that it takes at least 3 nodes to form a network. And when you form a network, there are 2 major entities, which are nodes and links, which made up a network. Then there are 2 types of nodes, terminal nodes and communication nodes. Terminal nodes are those nodes which generate or consume the information, but communication nodes are in between nodes, which probably are, we will probably read more about them. And then between the nodes, there are links, and these links can be categorized based on their physical behavior, or based on their information direction, transmission, or based on how they form a network. So more on this on the next class on Wednesday. So if you have any queries, you can put it right now, or we can